Okay, so variables, part 1. So literals. Literals are values that can be interpreted in only one way, so in a single way. So some examples of what literals are, we have Sahil, that could be a literal. We have any sort of whole number, so we have -10 to maybe even 36, that could be a literal. We have any sort of decimal number, so 3.14, that could be a literal as well, and any sort of symbol or character, so M or an asterisk. All right. So notice one thing when I was writing out these literal examples, that the first one, since it was a string of letters, I actually enclosed them within quotes. So any sort of text representation of anything, we always enclose them in quotes in Java. And then the last example with the M and the asterisk, whenever we're writing some sort of symbol or character or letter, a single letter, we enclose them in single quotation marks. All right. So now let's look at variables. So variables are containers that hold specific sorts of data or data types, but the data they store can change, and we'll get into that in a minute. But let's look at the first part. Variables are containers that hold specific sorts of data, and those are known as data types. So what are data types? There are two main sort of data types: primitives and objects. Now we all know that primitives are slightly simpler than objects. And in Java, there are actually eight sort of primitives, but we'll be looking at only 4 of them. So let's look at the 4. We have int, double, boolean, and char. All right. So in addition to this, we have byte, long, float, and a lot more. But we're going to be looking at these 4. Now let's explain the function of what each of these do. All right. So an int sounds like an integer. So using some common knowledge, we know that integers are any sort of whole real numbers. So just as you guessed, ints hold whole numbers. Whole numbers. So that can be any sort of negative number to any sort of positive number, like 1 billion. All right. So now doubles, they also hold some sort of numerical value. However, their numerical value is in terms of decimals. So they store numbers with decimals. So they hold decimal values. All right. So booleans, they test the trueness or the falseness of anything. So they basically have only 2 sorts of outputs that they can generate. So that would be true or false. So they declare if something is true or if something is false. So that's all that a boolean does. And notice how in a boolean, when it outputs true or false, is not actually in quotation marks. So that means that true and false is not a textual representation of anything. It's just a value that is given to something. All right. And now char is essentially any sort of letter or character or symbol. So that's what chars are. Any sort of letter, character, or symbol, and they are enclosed within single quotes. All right. So now let's look at objects, the more complicated type. So objects, there are a lot of types of objects that we can create, but one of the most widely used ones in Java is called the string. So let's look at objects, and the most used one in Java are called strings or string. All right, and notice one difference right off the bat between primitives and objects. When we are declaring the object, we actually start with a then uppercase s, and whenever we declare any sort of primitive, it actually starts with a lowercase letter. All right. So what do strings do? So strings, they're objects. So they hold words or sentences. They hold words or sentences. So an example of what a string would be, it would look something like comp sci is fun, exclamation mark, end quotation. So that's how a string looks like. Strings can hold any sort of thing like numbers or Boolean values or chars and put them into a sort of string or sentence or a word. All right. But one thing to note that whenever we actually, like for example, put in numbers into a string, we cannot add one string to another string that has a number in it. We cannot add that to, like, let's say we have a string that has 5 and another string that has 5. We cannot add that to create 10. These are just textual representations of the number 5 and the number 5. So I'll just put it together and make 55. All right. So that's what I mean by strings can have numbers or any sort of things in them. All right. So now let's look at the part in which the data they store in the container can change. So let me grab a different pen. So let's look at primitives first. So let's say we have integer or int a, which is equal to 6. And we haven't learned how to declare or create any variables. We'll get into that the next video, but I just want to give you some perspective here. So let's say we have int a is equal to 6. And then now a in its little container, it holds 6. All right. And now, somewhere later in my code, I want a to equal 1,000. So now, instead of a holding 6, a is going to actually contain 1,000. So that's simply how primitives can change their values that they hold in it. All right? But the thing with objects, they're a little different. They actually don't contain the actual value in the container. They actually have memory addresses that have it inside the container. So what I mean by, so let's say we create string stir is equal to hi. All right? So string stir is equal to hi. So this would actually store in stir, it would store hi, like so. And actually, whenever we create an object, it creates a memory address. So let's say this memory address was 135. This hi was stored in memory address 135. Okay? So now we want to say stir. We want to say stir is now equal to by. All right, so now instead of holding 135, instead of stir holding 135, it creates a new memory address for this. So we get rid of that and we create a new memory address. Let's say it's like 179. So now stir holds by at 179. So notice how we did not get, so in the primitives example, we got rid of this 6 and we totally replaced it with 1000. Over here, we just created a new memory address. So we did not get rid of this 135 memory address. We did not erase that completely. We just created a new memory address. So now let's look at char values. So chars are actually very interesting. One question you might be asking right now is, hey, chars have letters, characters, and symbols, and all that things that strings have, but string is an object, so why isn't char an object? Well, to explain that, we're going to look at a little more into chars, so char values. So chars, as we said, they display symbols. But here's the cool part. Chars are stored as numerical values due to the binary system. So thus, every single char value has a designated integer value associated with it. So we like to call these values ASCII values. And there are 4 main ones we look at. We have A, we have capital A, we have space, and we have a 0. All right. So now let's look at the numbers associated with it, or the int values associated with it. So the lowercase a has a 97, or stored as a 97. Capital A is stored as a 65. The space is stored as a 32, and the 0 is stored as a 48. So now to give you some perspective here, since lowercase a, for example, is 97, lowercase b would be 98, c would be 99, d would be 100, so on and so forth. Same thing with capital A. It will just go in a increasing order as you progress through the alphabet. And now these ASCII values will be really helpful when we're actually going into strings, and we're going to see some applications of them